Today I'm going to talk about our project, Science Curiosity. So our topic today is the relationship between the speed of a moving subject and time dilation. So I'm going to talk all of the things in three parts. First, why will time for a subject slow down when it is accelerating? Second, what's the relationship between time and acceleration? And third, which is most people interested in, how can we stop time? So now for our first question. First, we're going to do some presupposition. So here is two mirrors and a photon is bounced back and forth between them. We can just assume that it bounced back and forth for 1 second. And there's also a spaceship which is moving forward. We can assume that it moves like in a very fast speed. So now look at this graph. So this is when a photon bounces back and forth once, from the bottom to the top and then to the bottom. So the upper picture is what a static person outside the spaceship will see, because the photon is not only moved directly up, it also moves forward following the spaceship. And the second picture below is what a person in the moving spaceship sees, for if he or she is in the spaceship, he can feel the spaceship is moving. So in these pictures, we can find that it moves a longer distance for the same bounce inside the spaceship than out of it. And we can also know as photons is massless, photons always move at the speed of light. So the distance is longer and the speed is same, then we can know it takes a longer time to bounce once in the spaceship, therefore 1 second is longer in the spaceship. Okay, so now for our second question. Here are some variables we're going to use. C is the constant speed of the photon, V is the constant speed of the spaceship, and T is the time that passes outside the spaceship, T prime is the time that passes inside the spaceship. So looking at this picture, we're going to figure out some very important distance. As we can know, distance equals to speed times to time, and V times T is the distance the spaceship traveled. C times T is the distance the photon traveled as seen by a static person, for it is traveled like a slope line. And C times T prime is the distance the photon traveled as seen by people inside the spaceship, for the people inside the spaceship will just see the photon go directly up and down. So, if we know T, which is the time that passes outside the spaceship, what is the number of T prime? As we notice that it forms a right triangle where we can use the Pythagorean theorem. So Vt squared plus Ct prime squared equals to Ct squared. Then we can find the relationship. So the relationship is T prime equals to the root of 1 minus V squared divided by C squared times T. Now for the third question, which most people is interested in. How can we stop time? To stop time, we need to make time never passes, and we know that T prime is the time passes inside the spaceship, so we want T prime is always equals to 0. So here is our relationship, and if we want T prime is always 0, we need to make the root of 1 minus V squared divided by C squared to 0. For 0 times T is always going to be 0. And if we want to make the root of 1 minus V squared divided by C squared, we need to make V squared divided by C squared is 1, for 1 minus 1 is 0. And furthermore, if we want that to be 1, we need to let V become C. And we know that C is the speed of light, V is the speed of the spaceship, so that means if we want to stop the time, we need to reach the speed of light. That is impossible based on our nowadays current technology, but we can try to make it become truth in the future. So that's all for today. Thanks for watching. See you next time. Here are some sources.